10.5, 10.6, scientific notation. Two lessons, so your homework might look a little bit different today, but they both go hand in hand as I deal with scientific notation. Today, our goal will be identifying numbers written in scientific notation, being able to write them in standard form, and comparing them. That's with the first lesson. But again, they both go hand in hand. When we talk about scientific notation is a number represented by the product of a factor and a power of 10. Now, that factor is a number greater than or equal to 1, but less than 10. So it can be 1, but it cannot be 10. Algebraically speaking, it's right here. Here's that factor. There's going to be some number in the front. It could be 1 or anything that is less than 10. And then we're going to have times 10 to some power. Every scientific notation is going to look like that. Now, your calculators will display it a little bit differently. Here's how it's displayed on calculators. They have an E or sometimes an EE or a capital E and a capital E with that number after it. That's just how they display it. So when you're looking at that, that's how your calculator, depending on what one you might have. But we are going to be writing it like this here on the bottom. So you're going to see this all the time today. Some factor, some number that could be 1 or anything less than 10, and then times 10 to some power. Up first, tell if the number is written in scientific notation. First, do we have a factor? Is this number between 1 and 10? Is it 1 or something less than 10? It is, so that's correct. And then here, do we have a power of 10? 10 to some number, some exponent, and we do. So our answer is yes. And now since it says to explain, tell all the numbers written in scientific notation, just tell me those two things. It has a factor between 1 and 10 and a power of 10, or just explain it like our definition talked about. It needs to have that factor that's equal to 1 and less than 10 and a power of 10. So this is not the only way to phrase it, but one of our answers. Looking at this, here we go. Next one. First off, going in order like we did, do we have a factor that is 1 or less than 10? No, we do not. Thus, again, here our answer is no, but just going through here, we can see we do have a power of 10, but not a factor. They both must be true. So then this one again, no. And now you have multiple different choices. You could say that the factor is less than 1. You could say that the factor is not 1 or a number less than 10. You could just say multiple different ways. You just need to explain which one of the two things it did not follow. Lastly, be very careful. Again, here's that factor. It can be 1, but it must be less than 10. Thus, this does not work. Here, another one. Do we have a power of 10? No. So our answer to this one is definitely no. Again, how do you want to explain this? No. 10 can't be the factor? Great. The factor is not 1 or less than 10. Cool, that works as well. You could also say it does not have a power of 10 if you wanted to say both of them. 10 can't be the factor. It must be less than 10 or equal to 1. And it does not have a power of 10. That works. You just need to justify your answers. Now, when we talk about writing, we're going to be looking here at this exponents to figure out how to write in scientific notation and in standard form. We just need to remember which way to move the decimal. When it's negative, when the exponent is negative, we're going to move the decimal to the left. Negative numbers are small numbers. Thus, our answer, for me, I've remembered, our answer is going to be small, or a negative number is tiny. So our answer in standard form is going to be teeny tiny number. You just need to remember somehow. When you're looking at it, same thing, positive numbers. When we talk about a positive exponent, it's going to move to the right. A positive number is a big number, so we're going to have a big number in standard form. You just need to remember which way to move the decimal and count correctly. So whatever trick, method, thought's going to work for you. Writing in a standard form. Here we go. That exponent is negative. So because it is negative, we need to move the decimal to the left, or we need to make it a teeny tiny number. So grab the decimal and move it 1, 2, 3 places to the left. And I always make the decimal larger than it needs to be so I can clearly tell where it is at. So in standard form, we have 0.00275. I will put a 0 in front because I like that. I can clearly tell it's supposed to be a decimal and not a dot, speck, or spot where you sneezed. That's standard form. It's just in normal writing, it's with a decimal. All we do is we look at that power. Because it is positive, we're going to move it to the right to make it a large number. Now, I sometimes find it helpful to write that number somewhere else. That way, when I move the decimal, I have room to move it 1, 2, 3, 4, 5, 6, 7 times. Count very carefully. Fill in every open gap with a 0, and when you rewrite your answer, once again, count very carefully. 1, 2, 3, 4, 5. Our answer should have 5 zeros in it. 1, 2, 3, 4, and 5. Feel free to put commas in if you'd like to, so that way it's easier to see that that number is 63,800,000. But you don't have to, but it is much helpful. And that's in standard form. And if they give us scientific notation with no decimal, there's nothing wrong with that either. There's that exponent because it's positive. Which way do we move it? To the right to make it larger. So I'm going to write that number, that factor in the front, down so I have room to move my decimal 6 times. Since there is no decimal, remember, it's right here at the end, so move it 6 times. 1, 2, 3, 4, 5, 6 times. Again, I make that decimal at the end larger, more obnoxious, so that way I remember where it's supposed to be and I can tell which one it is. And then you've got your final answer. Rewrite it. 1, 2, 3, 4, 5, 6 with commas in it. You've got that original problem and then your answer. Write those down for your work. Now, we're going to play a game. Used to be on a couple of late night shows called Will It Float? You don't need to write that on in, but that's what we're talking about here. An object with a lesser density than water will float. If it's greater than water, then it sinks. So what we're looking at is right here, we've got water's density, 1.01 and 0.1 times 10 to the third kilogram per cubic meter. And we're going to compare that to this ear of corn, which has a density of 7.21, 7 and 21 times 10 to the second power kilograms per cubic meter. What happens to the ear of corn when it's placed in water? What we're looking at is we're comparing them. We're going to compare these two scientific notations. If the object, in this case the corn, is lighter or smaller than water, it will float. So you can look at it, and that's what I'm going to do right here. I'm just going to compare those powers. I've got water at 10 to the third and an ear of corn at 10 to the second. Since they're both correctly written in scientific notation, the one that is smaller, the one that is lighter, is the ear of corn. Since corn is lighter than water, it will float. What will happen to the ear of corn when it's placed in water? It will float. If it says to justify your answer, that's where you're just going to explain that the ear of corn's density is lighter or less than water's density, therefore it will float. But since it doesn't say to, that's all we need. A female flea consumes about 1 4/10 times 10 to the negative 5 liters of blood per day. A dog has 50 female fleas. How much blood do the fleas consume per day? Here's a good thing. When it says write in standard form, we're going to take this guy, I'm going to write that in standard form right away. So because it is a negative number, please remember, which way do we move the decimal? For me, I remembered negative number, tiny, so I'm going to take that 1.4 and move that decimal 1, 2, 3, 4, 5 times. We'll write that number over here. Count very carefully. Don't lose one of those zeros. 1, 2, 3, 4 zeros. 1, 2, 3, 4 zeros. Good. And again, we've got 50 fleas, so if they each consume this much, we're going to take that number we've got right here times the 50 fleas. So grab your handy-dandy calculator, type that on in, and that's where you'll get that answer that we can leave in standard form, because they said we could. Again, count very carefully. If you miss a zero, so sad, you're close. Make sure you get all those zeros in there. So your final answer, 0.0007 liters. Again, just show me the work when we talk about these word problems. So show me this work that you typed into your calculator. Give me that answer. It's set in standard form, so you're set to go. 7/10,000ths of a liter. Good thing they don't consume very much. Now, moving on to part 2, writing in scientific notation. Please remember, when we talked about that, we want a factor, and then we're going to have times 10 to some power, to some exponent. But this number here has to be a factor between 1 and 10. It can be 1, but it must be less than 10. So wherever the decimal's at, start there, and now just keep moving it, until this number is between 1 and 10. It can be 1, but it cannot be 10. So right now, if I stopped here, I've got 24.5. That doesn't work. I've got 2.45. This 2.45 is between 1 and 10. Again, it can be 1, but not 10. And now you count. How many times did we move that decimal? 1, 2, 3, 4, 5, 6 times. So you're going to put that factor, that power of 6. That's it. Scientific notation. Because it's a large number, it's a positive exponent. Our next example. When we talk about writing in scientific notation, we need a factor. So I'm going to start here. I'm going to talk about moving the decimal. Since there is a decimal, start there, move it until the new spot where you have it is a number that could be 1 or less than 10. This is 0.45. This does not work. This is 4.5. So that'll work as our factor, 4.5, times 10 to the, now we go back and we count again. How many times did we move that decimal? 1, 2, 3, 4, 5 times. So we're going to have a 5. Now the question becomes positive or negative 5 on that exponent. Because this was a teeny tiny number, because this was a decimal, it needs to be a negative. And the last one down here. Move that decimal. We know it's going to be times 10 to some power, so we're just going to move the decimal. 1, 2, 3, 4, 5, 6. Keep moving it. 10, it cannot be 10, so don't stop here. Move it one more. So the answer is 1. You could put down 1.0, but all these extra zeros at the end here, they're all trailing zeros, so you don't need to write the extra zeros, just like our first example. So you can just write down the 1 times 10 to the 10th power. Count very carefully. Here's a little life hack, a little tip for you. The commas, you can count. They're 3s. So here's 3, 6, 9, plus 1 more gives you 10. So you don't have to draw the lines underneath. I do find it very useful. Please remember, when we're talking about these, you're going to write out that original problem and then that answer. That's what I'm looking for on your book assignment. Here we go. Music album receives an award when sells, let me say that number right, 10 million copies. An album has sold 750,000 copies so far. How many more copies does it need to sell? Write your final answer in scientific notation. So I would recommend, before we do anything, let's deal with those numbers in standard form first. It needs 10 million. They have sold 750,000 so far. Calculator, mental math, all approved. You're going to find out that they need to sell 9 million, excuse me, let me make that look more like a 9,250,000 more albums, which is great. But now we're going to change this number into scientific notation. Scientific notation has a factor with a power of 10. So here we go, moving that decimal till we find a number that is between 1 and 10. It could be 10. 92.5 does not work. 9.25 does. Again, I'm just going to write down those numbers. All those zeros here at the end, you don't need. So 9.25. Again, you don't need to show this moving of the decimal. You want to? Great. You can just move it mentally if you want, and then put those in. Again, like I said, you can use those commas as a little bit of a life hack. So here's 3, and that would be 6 right there. There's only one right answer, positive or negative 6 on that exponent. Remember, because we're dealing with a large number over here, this needs to be a positive number. So our final answer will be a positive 6 for that. Please note, it is a word problem, so we should probably put in a label, copies or more albums. Order these from falling from least to greatest. Always read the question. Be very careful. So if it says the least, we want the smallest. Notice they are all in scientific notation. All have factors that are 1 or something less than 10, and they all have a power of 10, which is great. That's how scientific notation should be. Now, put them in order from least to greatest. So which one of these is the smallest? When we compare our exponents, that's what we're going to do. We've got 2 of them with the 4s. So we're going to look at those 2. Of those 2, we've got 6.8 or 6 8/10 times 10 to the 4th and 5.65 times 10 to the 4th. Looking at those numbers just as they are, you can compare them. And since 5.65 is smaller than 6.8, we could put them in order. 5.65 times 10 to the 4th. It's this guy. 6 8/10 times 10 to the 4th. And this larger exponent here, larger power of 10, makes it the largest and the last. 2 4/100 times 10 to the 5th. That is one way to solve it. If you'd like to, you can write all those numbers in standard form. So we could have switched this and moved it 1, 2, 3, 4 times so that number would have been 68,000, which would make this number move it 1, 2, 3, 4 times. 56,500, and then move this 1, 2, 3, 4, 5 times, which make it 204,000. Then you can order these numbers from least to greatest. Please note, when you do that, when you number them or order them and you say this one's first, this one's second, and this one is third, I want to see the original numbers. So your final answer needs to have the original numbers written as they were in scientific notation. Today's goal, you can write large and small numbers in scientific notation and perform some operations with numbers written in scientific notation, as well as know which ones are or aren't in scientific notation.